Okay, now that's the present situation. Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it. It's true, however, that one has to check a little bit to make sure that it's wrong, because someone who did the experiment may have reported incorrectly, or there may have been some feature in the experiment that wasn't noticed, like some kind of dirt and so on. That's an obvious check. Furthermore, the man who computed the consequences, even it may have been the same one who made the guesses, may have made some mistake in the analysis. Those are obvious remarks. So when I say if it disagrees with experiment, it's wrong, I mean after the experiment has been checked, the calculations have been checked, and the thing has been rubbed back and forth a few times to make sure that the consequences are logical consequences from the guess, and that in fact it disagrees with a very carefully checked experiment. This will give you somewhat a wrong impression of science. It means that we keep on guessing possibilities and comparing it to experiments, and this is to put an experiment on a little bit weak position. It turns out that the experimenters have a certain individual character. They like to do experiments even if nobody's guessed yet. So it's very often true that experiments in a region in which people know the theorist doesn't know anything, nobody's guessed yet. For instance, we may have guessed all these laws, but we don't know whether they really work at very high energy because it's just a good guess that they work at high energy. So experimenters say, let's try higher energy. And therefore, experiment produces trouble every once in a while. That is, it produces a discovery that one of the things that we thought of is wrong. So what I would say, if experiment can produce unexpected results, and that starts us guessing again. For instance, an unexpected result is the mu meson and its neutrino, which was not guessed at by anybody whatever before it was discovered, and still nobody has any method of guessing by which this is a natural thing. Now you see, of course, that with this method we can disprove any definite theory. If you have a definite theory, a real guess from which you can really compute consequences which could be compared to experiment, then in principle we can get rid of any theory. We can always prove any definite theory wrong. Notice, however, we never prove it right. Suppose that you invent a good guess, calculate the consequences, and discover that every consequence that you calculate agrees with experiment. The theory is then right? No, it is simply not proved wrong. Because in the future, there could be a wider range of experiments, you could compute a wider range of consequences, and you may discover then that the thing is wrong. That's why laws like Newton's laws for the motion of planets last such a long time. He guessed the law of gravitation, calculated all the kinds of consequences for the solar system and so on, compared them to experiment, and it took several hundred years before the slight error of the motion of Mercury was developed. During all that time, the theory had been failed to be proved wrong and could be taken to be temporarily right, but it can never be proved right because tomorrow's experiment may succeed in proving what you thought was right wrong. So we never are right, we can only be sure we're wrong. However, it's rather remarkable that we can last so long. I mean, have some idea which will last so long. Incidentally, some people, one of the ways of stopping the science would be to only do experiments in the region where you know the laws. But the experimenters search most diligently and with the greatest effort in exactly those places where it seems most likely that we can prove the theories wrong. In other words, we're trying to prove ourselves wrong as quickly as possible, because only in that way do we find progress. For example, today, among the ordinary low-energy phenomena, we don't know where to look for trouble. We think everything's all right. And so there isn't any particular big program looking for trouble. in nuclear reactions or in superconductivity. I must say I'm concentrating on discovering fundamental laws. There's a whole range of physics which is interesting in understanding at another level these phenomena like superconductivity and nuclear reactions, but I'm talking about discovering trouble, something wrong with the fundamental law. So nobody knows where to look there, therefore all the experiments today are in this field of finding out a new law are at high energy. I must also point out to you that you cannot prove a vague theory wrong. If the guess that you make is poorly expressed and rather vague, and the method that you use for figuring out the consequences is rather a little vague, you're not sure, I mean, you say, I think everything's because it's all due to Muggles, and Muggles do this and that more or less, so I can sort of explain how this works, then you see that that theory is good because it can't be proved wrong. If the process of computing the consequences is indefinite, then with a little skill, any experimental result can be made to look like an expected consequence. You're probably familiar with that in other fields. For example, A hates his mother. The reason is, of course, because she didn't caress him or love him enough when he was a child. Actually, if you investigate, you find out that, as a matter of fact, he did love him very much and everything was all right. Well, then, it's because she was overindulgent when he was a child. So by having a vague theory, it's possible to get either result. Now, wait. Now, the cure for this one is the following. It would be possible to say, if it were possible to state ahead of time how much love is not enough and how much love is overindulgent exactly, and then there would be a perfectly legitimate theory against which you can make tests. It is usually said when this is pointed out, how much love is and so on, oh, you're dealing with psychological matters and things can't be defined so precisely. Yes, but then you can't claim to know anything about it.